Good day. I'm Shaun, and I'll be teaching general chemistry. And our topic for today is kinetic molecular theory of gases. So in this lesson, we will discuss first, a quick review on pressure and gas laws. Second, kinetic molecular theory of gases. And third, how the kinetic molecular theory explain the gas laws and gas behavior. So pressure, as discussed back then, is a measure of a force a gas exerts on a surface. Given by this formula, pressure equals to force applied over the area. And in this lesson, we will determine how do individual gas particles create this force. So for the gas laws, we have Boyle's law. In Boyle's law, increasing the pressure of the system decreases its volume and vice versa. In Dalton's law, the total pressure of a system is a sum of the partial pressures of the individual gases. In Charles' law, increasing the temperature of the system increases its volume. And in Avogadro's law, increasing the amount of gas increases the volume of the system. While we know that these laws hold true, they're actually arrived empirically or by experiments, but we still don't know why gases behave this way. To answer this question, it requires a theory that explains gas behavior at a molecular level. And that theory is called the kinetic molecular theory. The kinetic molecular theory explains macroscopic gas behavior at the level of individual particles. And the gases that conform to the postulates, which we'll discuss later on, in this theory, behave as ideal gas. So this theory is developed in the 19th century, and it was able to explain the gas laws that were arrived empirically or by experiments. So in this theory, we have 5 postulates. For the first postulate, it states that a gas consists of a large collection of individual particles. The volume of these particles are extremely small compared to the volume of the container. We can also say that the distances between the molecules, or the empty space between the molecules, is much greater than the volume of the molecule themselves. In the second postulate, it states that gas particles are in constant, random, and straight-line motion, except when they collide with the container walls or with each other. In the third postulate, it states that the collisions that occur in gases are elastic. By elastic, we mean that the total kinetic energy before and after collision will remain constant, thus conserved. In the fourth postulate, it states that there are no attractive or repulsive forces between gas particles. And in the fifth postulate, it states that the average kinetic energy of the gas particles is dependent on the absolute temperature. We can also say from this postulate that for a given temperature, the average kinetic energy of all the gas species is the same regardless of the identity of the gas, whether it be oxygen or hydrogen. So what does this theory explain? So it explains first the origin of pressure, then the gas laws such as Boyle's law, Dalton's law of partial pressures, Charles' law, and Avogadro's law. And now we relate the kinetic molecular theory on the origin of pressure and gas laws. So how does the kinetic molecular theory explain the origin of pressure? So we know that when a moving object strikes a surface, it exerts a force. And it holds true also to molecular particles, such that when a particle collides with the container wall, it exerts a force. Therefore, increasing the number of collisions in the system increases the amount of force experienced by the container, and eventually increasing the pressure of the system. In Boyle's law, Decreasing the volume of the system will decrease the empty space between the molecules, thus increasing the number of collisions and the pressure of the system. How does it explain Dalton's law? So let's say we have a system containing gas B. If we add gas A in this container will contain more molecules. More molecules means more collisions, and more collisions would mean higher pressure. Therefore, we can say that each gas species exerts a fraction of the total pressure based on the mole fraction of that gas species in the mixture. How does it explain Charles' law? So let's say we have an initial volume and temperature. So if we increase the temperature of the system, it will increase the most probable molecular speed and average kinetic energy of molecules, thus increasing the number of collisions in the system. That phenomena will cause an increase in volume until the pressure is the same as it was before heating the system. How does it explain Avogadro's law? So looking at this image, we have an initial amount of gas in the mixture. Then we inputted some gas in the system. Thus, initially it will increase the amount of collisions in the system, thus increasing the volume until the pressure is the same as it was before adding more molecules. So to summarize, the kinetic molecular theory explains gas behavior at a molecular level, and the postulates describe particle volume, particle motion, and particle collision, which explains the macroscopic behavior of gases. And that ends chemistry.